Hi, I'm Gwen Gordon, and I manage the WM Keck Foundation Laboratory for Environmental Biogeochemistry. And today I wanted to give a short introduction to the Prepfast-MC. This is an unusual, many places have them. We actually worked with the company to develop and validate this instrument. What it's for is to take samples and purify them for isotopic measurement. So each isotope system we look at has to be validated. So we only have a handful at the moment. But the kinds of applications we have are for uranium isotopes, strontium isotopes, and calcium isotopes. So for instance, if you're an anthropologist and doing lots of radiogenic strontium, this is an ideal system because once you dissolve your sample, it will do the purification for you. So what I'd like to talk about right now is a little bit more about how this instrument works. It's important for users to understand that so they can understand both what its capabilities and its limitations are. So this is the actual instrument, and what it has is a probe in an autosampler, and then below we have a number of things. So the idea with this is that there is a small little column, which is right here, and that's an ion that has ion exchange resin in it. So you can pick different resins for different chemistries. And then you can place different reagents. So for instance, we have different reagents that can be connected down here. And what it will do is it has this bank of syringe pumps, and it will take a very precisely volume of different reagents and pass it through the column. So what will actually happen is you put your sample in the instrument, and then it's computer controlled, and you'll give it instructions about what program you want to use, whether you want to use a calcium strontium method, a radiogenic strontium method, a uranium method, or some other method you've developed. And the probe will go in and it will pick up the first sample. It will take it up in the tube using the pump, and it will pass it through this column. And the one element or elements of interest will be loaded onto the ion exchange resin, and all the rest of the matrix will be washed away. And the acid to do this is determined by the particular chemistry of your application. Then you can use a different acid to remove or elute that element off of the column, and it will then deposit it back into a new tube in a different rack. So we've done a lot of work to validate this. Some of the applications we're looking at, we look at naturally occurring uranium isotopes in rocks. And so often you want to do very high temporal resolution, so you need to run lots and lots of samples. In the old days, that meant lots of days in the lab, sitting, just dripping acid through. And that is very time consuming and tedious. With this, you don't have to do that. Some other applications we've done are we use a lot with anthropologists who want to run lots of strontium isotopes for looking at the mobility of ancient peoples. And so you can do a lot of samples very quickly and without as much work with this. We've also done calcium isotopes. So this can be used, for instance, we're working on it as a clinical measure of bone mineral balance. In addition, it's a very flexible system. So if you have a particular project that you're interested in, any chemistry you can do in the lab, we can probably do on this. It will take some method validation, but it's extremely versatile. So this is the Prepfast-MC. And one question you might have is, why would you want to use this? Why would you want to purify your isotope samples to measure them? And that's because we are trying to measure very precisely small differences in natural abundance of isotopes. And if you have other elements in your sample, it can degrade the quality of the measurement. So for instance, if you're measuring strontium in, say, a plant and strontium radiogenic isotopes, that plant will have naturally occurring rubidium. So rubidium 87 will interfere directly on strontium 87. And it can also just be if you have lots of ions in solution, they make the machine much less stable when we're actually measuring them. We typically measure at a multi-collector ICP-MS. So it's really important to get very clean samples.